Hello everyone. Today let's solve the problem. This one, breakup, right? So this was asked in the Codeforces round 364 division 1. Right. So let's see what the question states. You can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem. Let's see what the question states here. Just give me a second, 1 second. Yeah. So we are given n towns, right? So we are given n towns and m roads. We have been given n towns and m roads in the Berland, right? So we have been given n towns and m roads in the Berland. Two towns S and T want to disconnect themselves, right? So among n and m, among n towns and m roads, two towns S and T, right? Two towns S and T want to disconnect themselves. Each road has a closure cost, right? Each road has this one closure cost. I'll just write CC here. Each road has a closure cost, and each town can close at most one road, right? Each town can close at most one road. Each town can close at most one road. Just remember this one. This is very important, right? So we have to find up to two roads to disconnect S from T with a minimum total cost. That's what we need to find basically. What we need to find here, we need to find two roads to disconnect basically, right? So we need to find here two roads to disconnect this one S and T with a minimum total cost. Two roads to disconnect, right? So just remember this one. This is very important. One, what we need to find, we need to find two roads to disconnect S from T, right? We have to find two roads to disconnect S from T with the minimum total cost. With the minimum total cost. So that's what we need to find here basically. Right. So this is very important. That's what we need to find here. So if impossible with less than or equal to roads, then we need to print -1. If it is impossible, then we need to print -1. So this is also very important. Don't forget. We shouldn't forget this one, right? So if it is impossible with less than or equal to two rows, then this one we have to print -1 in that case, right? So here, let me read the question loud again. Just listen to this carefully. So we have been given n towns and m roads in the Berland. Two towns S and T want to disconnect themselves, right? Disconnect themselves. This is fine. This part is complete. So each road has a closure cost. Each road has a closure cost, and each town can close at most one road. Each town can close at most one road. We have to find up to two roads to disconnect S from T, right? So we have to find up to two roads to disconnect S from T with the minimum total cost. With the minimum total cost. If it is impossible, nothing but with less than or equal to two roads, then we have to print -1. Then we have to print -1. Just remember this one. Let me delete this one entirely. Yeah. Now let's get into the input output part. See here, we have been given 6716, and we have been given this input 216235 349, and the output that we need to get here is mainly 8, right? So with 2 and 27, right? So this is fine. So this is it for the input output part. So now we are familiar with the question, man. We have understood the question. Let's do one thing. Let's quickly discuss the approach followed by the complexities, and then let's write the code, right? First, let's quickly discuss the approach part. So let's do one thing. Let's consider the same first example for the input basically. All right, for the approach, sorry, this one, first input for the this one approach, right? So what is our main goal here? We have to disconnect 1 and 6. So this one is S and this one is T here. So I have said S and T, right, within the question while explaining the question. So this one is S, 1 is S, and 6 is T. So we have to disconnect 1 basically accordingly with the connect this one question criteria that they have given in the question. We have to disconnect the 1 and 6. This is nothing but the T basically. This one is nothing but S, and this one is nothing but T. So we have to disconnect 1 and 6 basically. Yeah, 1 and 6, S and T, using less than or equal to roads with minimum cost. That is our main goal. right? So that is our main goal. Let me explain this one step by step. So first step here, let me go with the first step here. Let me mention this one. We have to find the initial path from S to T. We have to find the initial path from S to T, right? So suppose example path we can consider 1 to 2, this one 3, 4, and this one 6, right? So this one, this is just the example path, right? So this is just the example path I have shown you, right? So we have to find the this one, we have to find any initial path from S to T. Again, we can have the multiple outputs. So for this particular problem, we can have the multiple outputs. Usually, if it is a bridge-based question, we'll be going with a bridge-based. This one itself, what do we call answer itself, right? So usually we'll be going with some algorithm that might be solved, and that we can make use of to solve the problem with the DFS orientation, or you can just go with other methods as well. Usually I prefer to go with a DFS along with the DFS orientation, right? So this is fine. Now this is fine. Let's move on with the second step. The first step is S to T. So I have shown you the example path, one of the example paths, right? So this is fine. Now, second step is we will try removing each edge in this path, this one individually. When I say we try removing each edge in this path individually, if removing an edge alone disconnects S and T, if removing an edge alone disconnects S and T, this one, what do we call? SNT, then we have to record that cost. We have to record the cost, right? So here no single edge suffices. Here no single edge suffices. So this is the second point. I hope this is clear. Let's move on with the third point. What if removing one edge still allows connection, right? What if removing one edge still allows connection? Then what we need to do, we have to find a bridge edge on the new path. We have to find the bridge edge on the new path. These kind of things, what it does is it actually elongates the code basically. So the code will be so long. So when we write the code, you'll get to understand basically, right? So we have to go with the intense optimization, as well as the helper methods will be this one. We have to include many helper methods for the structured code. So if removing one edge still allows the connection, then what we need to do, we have to find the bridge edge on the new path, right? Bridge is equivalent to removing it disconnects the path. Bridge is equivalent to the removing it disconnects the path, and we have to try all the combinations forbidden edge plus bridge. We have to try all the combinations here. Nothing but we have to consider forbidden edge as well as the bridge, right? In simple terms, if one edge still allows connection, these many things we have to do. If one edge still allows connections, right? So let me give here connections, right? So this is fine. Let me tell you one more thing again. If removing one edge still allows connections, we have to find the bridge edge on the new path, right? Bridge is equivalent to the removing it disconnects the path, and we have to try all the combinations, nothing but forbidden edge plus bridge. This you will understand when we write the code crystal clear, but you have to know what we need to do, right? That is the reason we discuss approach every time. So without knowing the approach implementation, so you are directly trying to implement certain things, that doesn't work, man, right? So now let's move on with the fourth one, this one, the final point or the fourth point here. So let me come to the final point here. So we have after this one, if removing one edge still allows connection, we have to find the bridge edge on the new path that we discussed already. Finally, what we'll do, we have to choose the combination with minimum total path, right? So minimum total cost, sorry. We have to choose the combination with minimum total cost. So I'll just come here, minimum total cost. We have to choose the combination with minimum total cost, right? Here what we will do in this case, in our example, we will remove 2 comma 3 as well as 3 comma 1. So this is also correct, right? So we will remove 2 comma 3 and 3 comma 1. So cost will be here in this case, cost will be 5 plus 3, right? So 5 plus 3, cost will be 5 plus 3. right? So again, we are choosing the combination with minimum total cost, right? So we are going with a removing edges 2 comma 3 and 3 comma 1, and cost will be here 5 plus 3, which will lead to 8 basically. The output that we got here is 8, which is equivalent to the output that they have shown for the example 1 within the question. So we can just go with the 2 and 2 7 as well, right? So we have to display that one, right? So this is fine. So the I hope the this one, what do we call, approach part is completely clear. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part, man. So what will be the time complexity here? The time complexity would be big of n into m. So why it is big of n into m here? So we will be going with the DFS for pathfinding, along with this one, bridge detection for each edge in the initial path. So the code will be extremely lengthier. I know this one, man. So see here, we will be going with the DFS for path finding. This is one thing. Bridge detection for each edge in the initial path. So overall time complexity would lead to big of n into m due to the DFS. So this is fine, man. What will be the space complexity? Space complexity would be instead, it would be big of n plus m, not big of n into m, because of the graph adjacency list, right? Graph adjacency list along with the parent bar visited arrays, along with the parent bar visited arrays, right? So this is fine, along with the parent bar visited arrays. So the time complexity and the space complexity for the code that we'll be writing in the future would be this one, big of n into m and big of n plus m respectively, right? So as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code, right? So I'll just come here. Yep. First, what I'll be doing. So yeah, let's go slow. So the code will be, as I've said, this will be lengthier basically. We'll be making use of the fast input output. Let's make use of the buffered reader instead of the fast scanner, custom fast scanner. Let's make use of the buffered reader and this one. How many seconds they have given here? We can solve this one within the 3 seconds, man. Memory is fine. Yep. Let's do one thing. Let's make use of the buffered reader and the print writer itself for the input. So let me type this one. We'll be making use of the fast input output. So let me import input output package along with the this one utility package as well. We'll be making use of different utilities as well, right? Let's go with util dot start. So this is fine. Now we have to make use of the class, right? Just go with class main as usual and just give any class name that's relevant to the question. Right, so this is fine. First, let's go with the edge class that stores the destination, edge ID, and the closure cost. So I'll just go with static here, class edge. This is fine. So within the edge class, so as I have said, uh, edge class, it stores the destination, edge ID, and the closure cost, right? So let me go with int2 ID as well as long W, and one more thing. So let's go with the initialization part. So this one will be int2 int ID, so long W, right? So this is fine. This will be this dot 2 equals to this dot ID equals ID, and the final one is this dot W equals W. So this is fine, man. I'll just come out of this one entirely. Now, let's do one thing. Let's go with the initialization part, man. Right. First, we have to go with the number of towns, roads, and breakup towns. So this one will be static. So we have to go with towns, roads, as well as the breakup towns, right? So this one will be int n m s t. This is fine. Then let's go with the adjacency list for the graph. So I'll just go with static again. So let me make use of the array list. So let me pass edge here. So that is the reason we have written edge. G, let me give the variable name G. Here, let's go with the endpoints of the edges. So this one will be static int x comma y. So this is also fine. after considering the edges of the this one endpoints of the edges, let's go with the cost to close each edge, right? So this one will be static long w. This is fine. Mm, this is cost to close each edge, right? So now let's do one thing. Let's go with the parent of the node in the DFS to find the initial path. Let's go with the parent and the parent edge, man. So let me go with static here and parent. This is also fine. So next static here this one in parent edge. So this one I'll just give parent edge here. This is also fine. Now let's do one thing. We have to go with the parent in the DFS after forbidding one edge. Also, we have to consider the edge ID used for forbidding one edge. These two things we have to go with. So I'll just go with the variables name parent2 as well as the parent edge2 man here. So I'll just go with static again. So this one in, let me go with the parent2. And so I should have copy pasted the same thing. All I had to add was 2 basically. Let me type this one. So this one will be parent edge2. It's fine. Now we have to go with the visited array for the DFS, timestamps for the bridge finding, marked edges which are basically bridges, and global time for the DFS, right? So let's write these 4 things. This one will be static boolean visited. This is fine. This one will be static int. So this is pin low, and this one will be static again. Let me go with a boolean here. Let me consider is bridge, right? Yeah. If you would have solved the this one graph-based problems, you would have definitely solved the problems on the bipartite graph. This one bridges solving certain problems using certain algorithms like Dijkstra's topological sorting, solving certain problems using DFS, BFS. These are common problems, man. This is fine. Is bridge. Finally, let's go with the global timer for the this one DFS. So I'll just go with static here in timer. This is fine. Now let's do one thing. Let's go with the minimum total cost that is found and the best solution edges, right? First, let's go with the minimum total cost found. So I'll just go with static long. So this one will be best cost, right? So let me initialize this one to the long max value, right? So this is fine, man. The next part would be static. So this one will be int best. This is fine. Best count. This is equal to 0. So this one will be best even. Best even equals -1. Best E2. This one, let me initialize this one to -1 as well. Right, so this is fine. What we have considered here, line number 31 and 32, minimal total cost found and the best solution edges. Now let's do one thing. Let's move on with the main method, man. So this is just the initialization part, not to worry. Now let's move on with the main method, right? So this is fine. Let me include here throws exception. So this is fine. Yep. As I've said, we'll be making use of the buffered reader and the print writer, right? So this one will be buffered reader. I just go with B, BR, buffered reader, new input stream reader of, let me go with from dot and let me go with the print writer. This one new print writer system dot out. This is fine. Now let's do one thing. Let's read N nothing but towns and M nothing but roads. And the question I had strictly mentioned, right? So this one we know. We are already writing the code, man. We are just reading. We have to just read N and M basically. So I'll just go with the string. Make use of variable name sp here. This one buffered reader dot read line. So this is also fine dot trim. This is also fine. Let me go with a split. So this is also fine. Yep. S plus. Yep. This is fine. We have to read n and m. So this is just this one. What do you call regular expression one? We have to leave the spaces and other stuff, right? So I'll just go with a sorry integer. Mm, so both are n and m both are integers, right? So this one I'll just give %. Here. So this one is p of 0. This is fine. Let me copy the same thing and let me do the same thing for m as well. So this one will be m, and instead of sp of 0, so this one will be 1. Yep. Now let's move on with the further steps. So we have to read SNT, meaning so we have to go with the breakup towns, right? So again, sp equals. So this one, let me copy this one entirely. So again, we don't have to mention the type, right? So we have already done that. Once is enough. Sp equals for this one trim split this one plus plus. So this is also fine. Again, instead of this one, what do we call n and m? We have to read SNT. We have to read SNT breakup towns, right? So let me copy the same thing. Let me make the necessary changes over here. And one more thing, this has to be zero based, not one based. So this is one based. So this has to be zero based, not one based, right? SNT I'm speaking of. So let's do one thing. So this remains same. SP of 0. This remains same till here. So let me add -1 for whole as it is 0 based, right? So this is fine. Now let's do one thing. We have to initialize the graph. So let me go with new array list. And this is fine. Let me go with the for loop here. This one int I equals 0, I less than n, I plus plus. So this one will be g of I equals new array list. This is fine. Yep. Yeah, we're done with the syntax part. Now let's do one thing. Let's read the edges and build the adjacency list. So this one I have to type this one again. So let's read the edges and build the adjacency list. So this one x equals new int of size. M we have considered, right? If I remember correctly. Yep. Uh, y equals. So this is same one. Let me copy this one. So this one will be new int of m itself. X and y also will be considering w. So this one will be new long of same thing m. The only change here is instead of the int we are going with long for the w. Now let's move on with the iteration part here. So for I equals 0, sorry, 1 second. Yeah, I less than m, I plus plus. So this is fine. 1 second, getting a call, just a second. Let's continue. So I'll just go with yep. So let me go with sp equals again the same thing. Where did I give here this one? Let me paste this one over here. This is fine. X of I. So this one will be integer dot pass, and so let me copy the same thing here. So let me paste it over here. Sp of 0. So this is 0 index, right? So this one has to be 1. That is 1. And let me go with y of I, same thing here. So this one is p of 1 minus 1, right? So this is fine as well. Now let's go with a w of I as well. So this one will be long dot parse long. This one we have to consider p of 2, right? Yeah, this is fine, man. Yep. Now let's do one thing. We are just going with this one. Uh, we are reading the edges and we have to build the adjacency list as well, right? Let's do that. So I'll just go with g of x of I. This is fine. let me make use of the add operation. Let me go with new edge y of I, comma I. This one will be w of I, right? So this is fine. G of so this one will remain y of I instead of the x of I. The same thing, add of, so this one will be new edge. Instead we'll make use of x of I over here, comma this remains same I, and w of I remains same, w of I itself. This is simple, man. Let me come out of this one entirely. Now comes the main point. So we have to initialize the parent arrays for the first this one DFS. Also we have to find the initial path from this one S to T. Let's do these two things quickly. First, let's initialize the parent arrays for the first DFS. So this one will be parent equals new int of size and fine. Let me go with a parent edge. This one parent edge new int of m. This is also fine. So this one will be n basically, right? This is also fine. Now I'll just go with the arrays. Let me give here arrays fill. So this one will be parent comma minus one, right? So this one will be parent comma minus one. So this one will be arrays dot fill parent edge comma minus one. So this is fine. Now what shall we do? Let's find the initial path from S to T. So I'll just go with if here, not of DFS. This one find initial path. So for this one, we haven't written this one. What do we call? The DFS find initial path method yet to use this one here, right? So we have to use that one, and then we have to write that one, and then we can make use of it, right? So I'll just go with the DFS find initial path method first. So this is just the DFS to find any path from S to T, right? So let me go with static here, Boolean. Let me leave the space here, man. Boolean. So this one is DFS find initial path, right? So let me pass the parameters u as well as int p. So we need u and p. So let me copy this one and let me paste it over here. Let's continue that one later. So within the main method, so we need this one u and p as the parameters. So within this method, first thing, so if, let me write the if condition, if u equals t, then we have to return true directly. This is fine. The next part is, let me make use of the for loop here. For loop, so this one edge e of this one g of u basically, right? So within the for loop, let's do one thing. Let's go with a simple if condition. We have to skip the parent edge initially, right? So this one if e dot id, if the value is equivalent to pe is the thing variable we have considered, right? For skipping, I'll just make use of the continue keyword here. Why this is not showing continue? Let me type continue. This is fine. Now let me initialize v2 e dot 2 here. This is fine. Now let's write the simple if condition again. If parent of v, the value is not equal to -1, or suppose if v is equivalent to s, then let's go with the continue keyword, right? So this is fine. Now let me go with the parent of v equals u. This is fine. Parent edge of this one v equals e dot id. This is also fine. Let me write the simple if condition here. If DFS find initial path, this one v comma e dot id basically. So then what we need to do here, we have to return true. So we have to return true. So this is fine. Now let me give return false here. Else we have to return false. So let me give return false. So let me come out of this one entirely. Now let's make use of this one DFS initial path within the main method, right? So this is fine. Where is this DFS initial path? What we were doing actually? I forgot, man. This we were finding the initial path from S to T, right? So this one, all I need to pass here is if DFS initial path, this is fine, S comma minus 1, then what I need to do, this one, if no path exists, then the cost is 0. So I'll just give here out dot println of 0. This is fine. Next one, again, let me do the same thing here. Here, let me go with flush or close. This is fine. Let me make use of the flush itself. Then we have to exit. To exit, I'll just make use of the return statement here. Right. So this is fine, man. Now what we need to do, we have to extract the edges on the initial path. What we need to do, we have to extract the this one edges on the initial path. So I'll just come out of this one entirely. So I'll just give here int. Let me make use of the current equals e. So I'll just go with the array list here. So this one array list of integer. So let me make use of initial path edges. So this one equals new array list. This is fine, man. Now let me go with the while loop. Current not equal to s. Then let me go with the initial path edges. That one which I considered just now. So let me give here capital E instead. Yep. Here also let me make this one capital E. Camel case. So this one will be add parent edge. This is fine. Let me give current here. This is fine. So this one will be current equals parent of this one. What do we call current? So this is fine. Now let me come out of this one entirely, man. So let's try forbidding each edge in the initial path. So let's go with a for loop now. So this one int. So we have considered EID, right? So this is not showing here. So we have not considered, I think. Yeah, this one from the initial path edges, right? Sorry. This one. Initial path edges we are considering individual. So this is fine. Let me go with a process forbidden edge, right? So here we have not written the process forbidden edge, man. So let me come out of, let me come here. Basically, let's do one thing. Let's write the process forbidden edge helper method, right? So this is helpful when, why this is helpful, basically, we have to check if the remaining forbid edge alone or with another bridge disconnects S to T. Disconnects S to T, basically, S from T, basically, in simple terms, right? So let me go with here static void. So this one will be process forbidden edges, right? So edge, it disconnects S from T, right? So this is fine. Int, so I'll just consider forbid edge as the parameter. So let me do one thing. Let me copy this one and let me paste it over here. So now, so that I can use it within the for loop, right? So this is fine, man. So we have to go with the EID. Let me pass the EID over here. So this is fine. So let's continue this one later. For now, let's do one thing. Let's write this one first. What do we call? Process forbidden edge helper method entirely. So basically, why this is used for? This process forbidden edge method to check if remaining forbid edge alone or with another bridge disconnects S from T, right? So within this one, let me go with a parent 2. So let's go with the initialization part, man. New int of n, right? So this is fine. Also, let me go with a parent edge 2 here, new int of size, again n here. This is fine. The next step would be arrays dot fill. So this one will be parent 2 comma -1. So this is also fine. So again this one will be arrays dot fill. This one will be parent h2 comma -1. This is fine. And finally let me go with the visited. Finally let me go with the visited is new boolean of n. This is fine. Next, let's do one thing. Let's go with a DFS ignoring the forbidden edge, right? So I'll just go with here boolean. Let me go with if the path exists, right? So this will be correct, I think. Correct variable name to use here. This is fine. Let me go with the path exists itself. So let me go with DFS. This one. We have to recurse this one, I believe. DFS find path with forbid, right? So yeah, let's do one thing. Uh, we will be making use of one more helper method named DFS find path with the forbid, meaning so we will be applying the DFS to find the path while skipping the forbid edge. Just remember this one, right? So this is fine, I believe. So let me go with static here. So this one will be boolean. Yep, boolean. So this one will be DFS find path with give capital P here, path with forbid. This is fine. So let me go with the parameters u as well as pa. Let me go with the p. So this one int forbid edge also we need. So let me do one thing here. Let's continue this one, or just go with, let me copy this one. So I have given if this one, right? Boolean path exists basically. Right? Path exists. So let me call the method here or the function here, right? So we can continue with this one later. For now, let's write this one. What do we call forbid edge? DFS find a path with a forbid helper method, right? So let's continue with the same. So now initially again, if u equals t, let's do one thing. Let's return. This is fine. I'll just go with visited of u. This one, let me give true here. This is also fine. Let me go with a for loop here. This one, edge e, g of u. This is also fine. So within the for loop, what shall we do? Let me go with a simple if condition. If e dot id p or e dot id, this one equals forbid edge we are considering, right? Forbid edge, then we have to skip. Then let me give continue here. Also the same thing here, and let me initialize v2 e dot 2. Same thing. Let me write the simple if condition again. If visited of v, then we have to skip. If already visited, we have to skip. Continue. Then let me go with the parent 2 of v. Let me assign this one to u, and parent edge to this one, parent edge to this one of v. Let me assign this one to e dot id, right? So the next part would be, let me go with a this one DFS find path with forbid. We are just going with a, how do we call uh, this one? We are just recursing here, right? In simple terms. So I'll just go with DFS find path with forbid itself, right? So this one will be v, comma, what are the parameters that we need to pass here? E dot id. So this one will be e dot id, and then let me go with a forbid edge. This one. We have to return the boolean value. This is fine. So else we have to return false. Let me give false here. This is fine, man. So this is it for the what do we call a DFS find path with the 4-bit helper method. So let's continue from where we have left. So here we have left with the uh, we called this one DFS find path with 4-bit helper method or the function here. So let's continue with the same. I forget things, man. What we were doing here. Just give me a second. We were making use of the DFS here just to ignore the forbidden edge, right? So we were going with the DFS ignoring forbidden edge here. So here in this case, I have to pass S minus 1 as well as forbid edge as well. So this is fine. Now let's continue. So we know that forbid edge alone disconnects S from T, right? So for that, let's write simple if condition here. If path doesn't exist, basically, not of path exists, then what we need to do, let me assign cost to W of this one. What we need to pass? Forbid edge here. This is fine. So then let me go with a simple if condition here. If cost is less than best cost. So this one, oh, I have already made use of this one. This is fine. Yep. Let me go with the best cost. Let me assign this one to the cost. So this is fine, man. So this one is best count. This is fine. Best count. Let me assign this one to the one. Best E1. So this is fine. Let me go with a forbid edge. This is fine, man. Finally, best E2, this one. Let me assign this one to the minus 1. We have to exit, so I'll just do one thing. Let me give a return here, just for the sake of exiting. So now let me do one thing. After return, we have to, let's move on with the further things. We have to find the bridges on the new path as well. So there are a hell lot of this one. What do we call? Again, initialization, right? So I'll just go with them. Let me go with the new int of n. This is fine. Low equals new int of n, again a size n. Let me consider here is bridge. Let me go with is bridge. Let me initialize this one to new boolean of size n. Again, this one has to be m, I believe, right? So we are considering is bridge. Yeah, this one has to be m basically. So let me go with arrays dot fill. What do we need to pass? We are just going with we are filling 10 with 0 initially. And let me go with again arrays dot fill. This one, what we are doing, we are filling so with 0. This is also fine. Now again arrays dot fill. This one will be visited. We are filling visited with the boolean value false. Now let me initialize timer to 0 and let me go with a DFS bridge, right? So we will be making use of the DFS bridge helper method, right? So let's do one thing. So let's write the DFS bridge helper method first, and then we can make use of it here. Right. So don't worry, this is going to be the last helper method. I know this is quite lengthier. So it's better to write the structured code, right? So I would have written entirely within the main method itself, right? So you'll not understand what we have done at all. So we are just splitting into the different helper methods, so we would know what we are doing in a structured way correctly, right? So that's what we are doing. So now let's make use of the DFS to find the bridges. So these are the critical edges, right? So ignoring the forbid edge. In simple terms, we are going with the DFS to find the bridges, ignoring the forbid edge. So let me go with static here. This is fine. Void. Let me go with DFS bridge. What are the parameters that we need? U as well as P as well as this one, forbid edge. So this one will be forbid edge. So within this helper method, so let me go with again the same thing, visited of U initially let's set this one to the boolean value true, and none of you, this one I'll just go with which is equivalent to the law of u equals less plus 9. So this is fine. The next step, iteration part. So this one, edge, individual edge from graph, basically g of u. Yep, we have to consider that, right? So within the for loop, what if e dot id, this is fine, is equivalent to the p, or again e dot id, what if it is equivalent to the 4-bit edge, this one. Then we have to skip, I mean we have to give continue, this is fine. Then let me initialize v to e dot 2, this is also fine. Let me go with the if condition, if visited of v, this is fine. uh, then we can just go with the law of u. This one I'll just give math.min here. This is fine. Let me go with law of u, comma, tin of v. This is fine. Yep. Next, let's do one thing. Else, what we will do, let me go with a this one recursion, or let's recurse here. Let me go with DFS bridge. Let me pass here v, comma, what are the things that we consider? E dot id, right? Also 4-bit edge, the parameter. Yep, this is fine. Now let's go with low of u. Let me assign this one to the, we have to find the minimum, right? So we'll be going with the math.min low of u, comma, low of v. This is fine, I believe. Finally, let me go with a simple if condition here. Low of v, if it is greater than 10 of u, so this will be is bridge of e dot id. Let me assign this one to the boolean value true, right? So this is nothing but when the bridge is detected, right? So if low of v greater than the 10 of u is bridge, so employee id, not the employee id. So e dot id, this one I'm remembering the SQL. Basically e dot id, whatever we have set this one to the true, right? So this is basically bridge when bridge detected, right? So this is fine, I believe. So we are done with the helper method, with this helper method. Right, so now let's do one thing. Let's make use of it here. Where did we leave? So this one here, right? So let's make use of this helper method DFS bridge, this one within the main method, right? So here where we had left one, just give me a second here. So 1 second. Initialization part, we are going with a parent edge. This one path exists. So this one we have already DFS find initial paths, right? This fine. Yep, we have done this one. We are going within the path exists method, right? 1 second. So this one boolean path exists. So we are writing the process forbidden edge helper method. No, not the main method. So we haven't completed this one process. This one, what do we call this method name? I forgot the method name itself. Process forbidden edge, right? So this one we have to complete first. Timer, we have initialized this one to 0, right? So yeah, let's continue, man. So this one, we have to find the bridges on the new path. For that one, we have already written the DFS bridges, DFS bridge helper method here. What did I name this one? Let me copy the same thing. DFS bridge. Did I name this one? DFS bridge. Yeah, let me paste this one over here. DFS bridge. Let me pass s comma -1. Also, what we need to pass 4-bit bridge itself, I believe. Yeah, bit bridge. This is fine. 1 second. Yeah. Now what we need to do, so we have to check with a bridge along with a 4-bit edge that gives the minimum cost, right? Initially, let me initialize the current to t, while let me go with this one, current not equal to s. Then let me go with e and let me assign this one to the parent edge to this one of current. This is fine if e equals -1. Then let me give break here. This is fine. Is bridge this one of e. This is fine. So within this if condition, what shall we do? I'll just go with the cost here. So this one will be w of 4-bit edge. So this one will be 4-bit edge less w of e. This is fine, man. Now let's write the simple if condition here. If cost less than best cost. So this is fine. Let me write the simple if condition. Within the if condition, we have already written the if condition, right? So I'll just go with the best cost here. Just 1 second. Let me go with the best cost. Let me assign this one to the cost, and also best count. Let me assign this one to the cost as well. Sorry, not the cost. We have to assign this one to the 2, right? So now let me go with the best e1 and e2. So this one best e1, let me assign this one to the 4-bit edge. Also finally best e2. So this one, let me assign this one to the e basically, right, edge. So let me come out of this one entirely. So let me assign current to parent 2 of, let me give current here. This is fine. Yep. So we are done with this. What do we call? Helper method. So we have made use of many helper methods. So this helper method, what do we call this one? Uh, Process forbidden edge basically. Right. So we are done with this helper method. Now let's do one thing. Let's make use of this one process helper. This one, what do we call? Process forbidden edge helper method within the main method. Right. So where is main method one? So this one where we have left. 1 second. Yeah, here, right? So process forbidden edge, we have already used this one within the for loop, right? So now let's move on with the same. So what we were doing, I just forgot. Just give me a second. Let me remember what we are doing in the main method. 1 second. Yeah, this is for trying the forbidding this one each edge in the initial path. So we had written the helper method, this one process forbidden edge for this, and I have called this one within the for loop. So this is fine within the main method basically. Now let's do one thing. We are left with only certain things. We have to output the best solution that we have found, right? So for that one, let's write the simple if condition. If best cost, this is equivalent to the long. Basically, I'll just go with a max value here. Then let's do one thing. I'll just go with the out. This one println. Let me go with a -1. Else, what we will do? So I'll just go with out dot. Let me go with a println of the best cost. Right. So this is fine. Out. Let me go with a println again. Let me go with a best count. This is fine. Now let me go with a simple if condition. So when best count equals 1, so let me go with out dot println. Let me go with best e1 less 1. This is fine. Next, else what we will do? Let's go with the out dot println. This is fine. So we have to go with the best e1, right? Best e1 plus 1. What we need to display here, we need space as well uh, within the output. Also we need best e2 plus 1 as well, the same thing, man. Similar to the E1. Let me consider E2 here. Best E2 less 1. This is fine. Mm, did I make any mistake here? So yeah, let me consider one more, this one, parenthesis here. We might get there. So this is fine. Finally, let me do one thing. We have to flush the output, or we have to close. So I'll just make use of the flush itself instead of closing. So this is fine. So we are done with the coding part. So before checking the code with a different, this one, what do we call? Output, sorry, inputs. So let me copy paste the signature starter template. This was really, this one. The code was huge. This is fine. Lines. This is fine. Yep. Just give me a second here. Let me come here. Let me paste this one over here. Yep. Let me come to the question. So let me copy this one. The output that we need to get here as 8227, and we can have the multiple inputs as well, man. Accordingly with the question. So we have so many errors, 2 errors. That's fine. Now this is warning actually. This is fine. Let's ignore this. And the line number 22, error cannot find the symbol. This I has to be capital. Line number 92. Where is 92? Let me go with I. This is fine. Let me run this one. Yep. We are left with only one error, that is cannot find the symbol time. Line number 192. 192. Yep. Okay. So this one I have given ton of you. 1 second, man. Oh yeah, I have considered timer, right? 1 second. Yeah, we have considered timer, man, not the time. I have not given R here. 1 second. Let me give timer here. Let me run this one now. For God's sake. Yeah, 8287. 8227. We are getting the correct output, right? So let's check the same, this one. The second input. We have to get 9245. So we are getting 9254. This is also correct, basically. 4554. This is fine. Let me copy this one. We have to get the output 112. Let me check this one. Yeah, we are getting the output 112. The final one, let me copy this one. Output we need to get -1. Impossible, right? Yeah, we are getting the correct output -1. So let me do one thing. This code is huge, basically. Let me copy this one entirely. Just come to this one. How much it is rated? Actually, 2600, man. Yep, this is extremely difficult. Yep, I wouldn't lie. This is for the division 1, right? Yeah, yeah. Yep. Let me do one thing. Let me, yep, break up. Let me paste the code and hit the submit. This one. Yep. This is the difficult one, man. I'm not gonna lie. Division 1, you have to be extremely intel. Not the intel. You have to know how to manage the time, basically, whenever you're giving contest within the division 1. Time is very much important. So you can just implement if you have the knowledge, no doubt. If you have the knowledge on the algos, as well as if you have the knowledge on what you're doing. So where to implement, how to implement, when to implement, you have to know these 3 things. And you have to be very good with the time, basically. I wouldn't lie. Time, managing time is very important whenever you are giving the contest, basically. You have to know how much time you have to give to which question that they have asked at that point of time. So time management is very important. This is fine. Yeah, you can clearly see here the verdict that we got here is accepted. So this one, how many? 3 seconds they had given. Okay, we have made use of we haven't made this one, made use of this one custom fast scanner. We went with the buffered reader and this one print writer, right? So we are, yeah, this is fine, man. The verdict that we have got here is accepted. And one more time, what we have made use of here, basically, so this is bridge based problem, right? So we have made use of the DFS, right? Pure DFS. This is DFS. Yep, DFS basically, right? So to solve this particular problem, it's we have went in the structured way. That's it. We have split the problem into the different helper methods, and we have solved. That is the reason the code is little bit lengthier. Not little bit lengthier. Basically, the code is lengthier, right? So this one is very difficult one accordingly with me for the implementation, right? So you can just implement again. As I've said, the time management when we are giving the contests, this one, the time management is very important, right? So this is fine. I hope the solution part is completely clear, man, along with the approach and the complexities. For now, this is it. Thanks for watching, guys.